In this chapter, we're going to introduce the inverse trig functions. So we've talked about sine, cosine, tangent, cosecant, secant, cotangent. Now let's talk about their inverses. Now, one thing that you may remember from 1050 is if a graph passes the vertical line test, then we say it is a function. If it passes the horizontal line test, then its inverse is also a function. So if we look at a sine wave passes the vertical line test. Any vertical line I draw only crosses the graph once. However, it does not pass the horizontal line test. And the horizontal line test, it actually crosses lots of times, which means its inverse is not a function. So we're going to do something called restricting the domain, which basically means I'm only going to look at a portion of the graph so that I can force it to pass both of these tests. And you'll see that portion highlighted in blue here. So we have picked to only look at this part of the sine wave. And if I only look at that blue part, then yes, it passes the vertical line test, and yes, it passes the horizontal line test. Only crosses through the graph once, which now means its inverse is a function. So when we're looking at sine, we are going to restrict the domain to negative pi halves to pi halves. That's what it's restricted to on this graph, which essentially means we're only going to look at quadrant 1 and negative quadrant 4 angles. So when we look at sine, or arc sine, the inverse of sine, we only want to look at quadrant 1 and negative quadrant 4 angles. Now, you might also remember from 1050 that to graph an inverse, you take these points and flip the x and y coordinates. So if you take these points and flip the x and y coordinates, you would get a graph that looks like this. So this is the graph of arc sine or inverse sine. And just so you know, these two things, arc sine and sin -1, are the exact same thing. They're just two different ways to write it. They both mean the inverse sine. And this is the graph of it. Now, a couple things I want you to notice. The domain of this graph goes from -1 to +1. The range goes from negative pi halves to positive pi halves. So that's a little introduction to our inverse sine function. Now let's look at our inverse cosine function. Now, same thing you'll notice, does not pass the horizontal line test. So we restrict the domain, only look at a portion of the graph so we can force it to pass both tests. In cosine's case, we restricted the domain to be 0 to pi. That is the portion of the graph we're keeping, from 0 to pi, to make it pass both tests. So for cosine, we're essentially looking at quadrant 1 and quadrant 2 angles. And same thing, if you take these x and y points and flip them, you're going to get this graph. So notice the domain of this graph goes from -1 to +1. The range goes from 0 to pi. So now that we've introduced our arc sine and our arc cosine, our inverse sine and our inverse cosine, let's try to do some problems with them. So we're going to start right here. I want to find arc cosine of 1/2. Just so you know, this is the exact same thing as saying cosine of theta equals 1/2. If I solve this equation for theta, I would do the inverse cosine on both sides so that those would cancel because they're opposites, they're inverses. And I'd get theta is the inverse cosine of 1/2 or arc cosine of 1/2. So when we're looking at this problem, we're essentially asking, what angle can I plug into this equation to give me a cosine value or an x value of 1/2. So think of our unit circle. Where is the cosine value or the x value 1/2? Well, the first one is going to be right here. That triangle has an x value of 1/2. And this triangle also has an x value of 1/2. So I've got two triangles here that will give me a cosine value of 1/2. Now the radians for these triangles are pi thirds for that one, and this one is 5 pi thirds, or you could also think of it as negative pi thirds. Now, previously when we had done problems like this, we had listed all of these answers. And typically we did like pi thirds plus 2 pi k and 5 pi thirds plus 2 pi k. However, this time we are restricting the domain. So remember, arc cosine gets restricted to quadrant 1 and quadrant 2 angles. So if it's not in quadrant 1 or quadrant 2, I don't want it. So I'm going to X that one. That one is not in quadrant 1 or 2, which means the only one I have left is pi thirds. And that is my only answer. So having done one together, I would like you to try this one. Pause the video, write what this means, what you're looking for, sketch out what triangle you're looking at, and then list the angle that is going to give you this sine value. Pause the video, try this one out on your own, and then come back to check your work. Let's see how you did. So we can rewrite this as sine of theta equals root 2 over 2. So we are looking at what angles give me a sine y or a y value of root 2 over 2. This triangle has a y value of root 2 over 2, and this triangle has a y value of root 2 over 2. However, for arc sine, we only want quadrant 1 and negative quadrant 4 angles. So I X this one out because that doesn't fit those, and I keep this one that's in quadrant 1. So that was pi fourths, so that is my final answer. Let's try another one. C, arc cosine of negative root 2 over 2. So once again, pause the video, sketch where this goes, find the angles that satisfy this, and then narrow it down to the one angle answer that we want. Ready, go. Let's see how you did. So we are looking for what angles give me a cosine or an x value of negative root 2 over 2. This triangle has an x value of negative root 2 over 2, and so does that one. This is at 3 pi fourths and 5 pi fourths, but cosine is quadrant 1 and 2 angles, so I don't want that one, which leaves me with 3 pi fourths. Let's try one more and then we'll be done with this video. Arc sine of negative 1/2. So sketch it out, try to figure out what angles will satisfy this, and then pick which of those angles we actually want. Ready, go. Now pay careful attention. This one might get you. So we are looking for what angles give me a sine or y value of negative 1/2. This triangle has a y value of negative 1/2. This triangle also has a y value of negative 1/2. This is at 7 pi 6, and this one is at 11 pi 6. Or, remember, we could also think of this as negative pi 6, negative going in the clockwise direction, pi 6. Now, there's a reason I write the or there, because arc sine is quadrant 1 and negative quadrant 4 angles. So that means I don't want that one. That's not the right quadrant. These are the right quadrant, but 11 pi 6 is a positive quadrant 4 angle. I want the negative quadrant 4 angle. So that's why I picked the negative pi 6 for my answer. So that introduces us to arc sine and arc cosine. In the next video, we'll start to combine these together and do multiple things at the same time.